So this is the first video in the series of critically appraising medical literature, and in this video we're just going to take a look at some of the key aspects that we need to understand before actually jumping into any sort of critically appraising or critical appraising. A lot of the times you're going to hear throughout the series me flipping through paper, and that's because I'm going to be looking through notes as reference in order to make sure that I'm not forgetting anything or reporting any incorrect information. But yeah, let's just jump into it. So throughout the video series, we're going to take a look at a couple of different study designs. The first study design that we're going to look at in a couple of videos are RCTs, or is RCTs. Then we're going to take a look at observational studies. Then we're going to have a look at prognostic studies, diagnostic studies, and systematic reviews, and meta-analyses. And we're going to look at the different features that comprise each of these study designs and how we can go about discerning whether or not it's a good RCT, a bad RCT, a good observational study, a bad observational study, and so on and so forth. So before we can actually start to jump into looking at any of this, we want to quickly take a look at some key terms and some key ideas that we need to understand in order to actually do any sort of critical appraisal. What did I just do here? Okay, there we go. Alrighty. So the first thing we want to take a look at are two very important definitions. And the first definition is internal validity. And what is internal validity? Well, it's basically asking the question, how likely is it that my results that I observed are caused by the intervention that I administered and not by something else? And the more likely that it becomes that my observed effect was because of my intervention, the more internal validity I have. External validity is my second term that I want to remember, and this term refers to the applicability of my results to the general population that I sampled from. So if my results are more applicable to the general population, I have better external validity. If my results really only represent the sample that I got from the population, then I have lower external validity. The next thing we want to do is take a look at the hierarchy of evidence. So what constitutes the highest form of evidence, what constitutes the lowest form of evidence, and why is it like that? So the lowest form of evidence we have are laboratory studies. Then we have observational studies, and then we have randomized controlled trials, or RCTs, and then finally we have systematic reviews and meta-analyses. And basically, how do I know, one of the questions is, how do I know that systematic reviews and meta-analyses, or RCTs, provide me with greater evidence? And why are they on the top of the hierarchy of evidence than laboratory studies, for example? And that has to do with internal validity and external validity. So as we move up the hierarchy of evidence, we're basically saying that our ability to support that cause and effect relationship between the intervention and the outcome, or the intervention and whatever it is that we're looking at, our ability to look at that cause and effect relationship has increased. So our internal validity is really increasing as we go up this hierarchy of evidence. So that's one of the reasons why systematic reviews and meta-analyses might be better than laboratory studies in the hierarchy of evidence. But then you might be wondering, well, what happened to my external validity? And the idea is that within each of these study designs, we actually have another hierarchy. So for example, in observational studies, we have case reports. We also have case series, we have case control, and we have case cohort, or just cohort studies. And within this study design, as we move up the hierarchy within only the study design, our external validity is increasing. So our ability to say, okay, my results are now applicable to the general population is increasing as I move from case report and case series to simply just case cohort. And the reason for that is because case cohort studies have some different features that case control or case reports or case series don't actually have, which make it more applicable to the general population. And basically this applies to laboratory studies, RCTs, systematic reviews, and meta-analyses too. So as we move up RCTs, our external validity is increasing. As we move up the hierarchy for systematic reviews and meta-analyses, our external validity is also increasing. So that's the general idea behind the hierarchy of evidence, and why something might constitute as better evidence than something else in terms of its clinical applicability and its the transferal of the evidence to a clinical setting. So now we could actually jump into a little bit of critical appraisal. And the first thing we're going to take a look at is the different types of research questions. Okay. So there are 4 types of research questions that we're going to take a look at. The first type of research question is therapy. Then we have harm. Then we have diagnosis. Oops. And then we have risk/prognosis. Okay. So you might be wondering, well, what do you mean by research questions? And why are these 4 different types of research questions? Well, they all ask different things. Therapy types of research questions are research questions that are looking to essentially ascertain beneficial outcomes or beneficial effects on a patient-reported outcome or any sort of outcome. Harm is kind of the flip of therapy, and it's trying to ascertain or look for the harmful effects of a certain type of intervention on patient-reported outcomes. The diagnostic studies, on the other hand, or diagnostic research questions, are research questions that are asking for essentially, is something able to differentiate between those with a target condition and those without a target condition. And risk and prognosis types of research questions are all about estimating a patient's future course. So if a person doesn't have a disease and has risk factors, then how likely is it that this person is going to get the disease? Or if they already have the disease, then how likely is it that they're going to progress to a worse form of that disease, right? And within each of these type of research questions, we have different components, but the general framework is called PICO. Really, it's called PICOT. This is just time. Basically, what this is each of these research questions has to have these components in order to fulfill the criteria of a research question. So P stands for patients or population. So basically the relevant people, the general population that you sampled from. I stands for intervention. C stands for comparison. O stands for outcome. And T stands for time. So for therapy and harm questions, we have basically the same format for PICO. So we're going to essentially say P will be the population that we sampled from. I will be the intervention that we're interested in testing. The comparison will be some sort of control. So it could be usual care. It could be, an active sort of ingredient in something, or a placebo or something like that. Outcome is whatever we're interested in, and time is just time. How long have we been looking at this outcome for? Diagnosis studies have a little bit of a different outline of PICO. So we still have PICO here, or PICOT. Right? Our P is still population, the relevant population. Our intervention is the test that we're interested in, the test that's going to be the new test that's going to differentiate between people with a target condition and without a target condition. Our C is going to be a gold standard. So the gold standard is something that's been established by evidence to be able to essentially discern for this diagnostic study its ability to differentiate between people who have the disease and who don't have the disease. And if our intervention shows similar results to our gold standard comparator, the C, then we can be pretty sure that our intervention is good also. And outcome is still, we're looking for, although we're still looking for whether or not the person has the disease or doesn't have the disease, here our outcome is going to be reported as sensitivity values, specificity values, negative predictive, positive predictive values, and so on and so forth. But we'll take a look at this when we actually get to diagnostic studies. And in risk and prognostic studies, again, P is still just population that we're interested in. I and C are actually grouped together this time. Okay? And I and C are simply just going to be the prognostic factors that a group of patients that you've collected have. So if a group of patients have some sort of risk factors that might make them more likely to become diseased, or if a group of patients have risk factors that might progress them further in their prognosis of the disease, then these are going to be our intervention and control. Our outcome is what we're interested in. So are they going to get a worse prognosis, or do they develop the disease? And T again is just time, right? So now that we've looked at the different types of research questions, and the different components of research questions, the next thing to look at is, well, aside from understanding what my research question is looking for, what is my research question really asking? So this is what we call framework. So it's actually called framing the research question. Okay, so we're going to take a look at a couple of different frameworks. The first framework that we have is an equality framework. Then we have superiority frameworks. Then we have non-inferiority frameworks. And then we have equivalence frameworks. Okay, and I'll talk about what these are in a bit. But basically, within each of these different types of research questions, I can have one of these types of research hypotheses or research frameworks. For example, in a therapy study, I might be looking for a beneficial outcome of my intervention. But am I looking to see whether or not it's equivalent to the control? Am I looking to see whether or not it's no worse than the control? Or am I looking to see whether or not it's better than the control? Like, all in all, I'm looking for whether or not it's having a beneficial outcome. But I still want to make conclusions of whether or not it's better than, it's non-inferior to, or if it's equivalent to. So that's what I mean by the framework or the research hypothesis. And we're going to take a look at all of these. And you might be wondering now, well, what's the difference between equality and equivalence? They're pretty synonymous. And the difference is that number 2, 3, and 4, superiority, non-inferiority, and equivalence studies, or equivalence hypotheses, these apply to basically studies that have gone to late phase 3. So equality studies then, or equality hypotheses, are only applicable to studies that are still looking at the proof of concept or still looking to demonstrate that they have consistency in the results. So they're not yet ready to make any sort of clinical interpretation. And the way that we evaluate equality studies is we're essentially given confidence intervals and p-values. And we want to look at whether or not that confidence interval excludes no difference, whether it includes no difference, and so on and so forth. And we'll take a look at this visually because it's a lot easier to actually represent this visually. So here's the diagram that is going to be repeatedly occurring. And let's just say that on this side, we're favoring our control group. On this side, we're favoring our treatment group. And this here is the line of no difference. Okay, so this represents basically no difference between control and treatment. And let's say, for the sake of it, that we've been measuring this in risk ratios, right? So this line then is risk ratio of 1, and of course that's because if you have a risk ratio of 1, then you're saying that between my intervention and control, there's absolutely no difference in the risk. Okay, so I could have a couple of different scenarios, and we'll take a look at these two scenarios here. And how do I know now which one's better, which one I can make a definitive conclusion for, right? And I have to look at my confidence intervals now. My confidence intervals is what I'm going to be looking at to tell me whether or not I can make determinate conclusions. This confidence interval, and I have to look at my upper boundary and lower boundary of my confidence interval. So this confidence interval, if I look at its upper boundary is telling me that, okay, I could favor the treatment group. Its lower boundary is telling me I could potentially favor the control group, right? So I'm confused. Is it favoring the treatment group or is it favoring the control group? I don't know. And this confusion is reflected by the fact that it crosses that no difference line, that risk ratio of 1. It could also be a mean of 0, for example, but it's crossing that no difference line. So whenever something crosses the no difference line, then we're uncertain of whether or not we can make any sort of definitive conclusion. When something crosses the no difference line, we also say that it is statistically non-significant, right? The p-value is going to be greater than 0.05 because we're not sure if there's an actual difference. Here, we can be certain that there is a difference. It's not crossing the no difference line. So suddenly our p-value is less than 0.05. We're statistically significant. And we can say, and we're ready to say, that one treatment might be equal to the other treatment that we've been given, our control, for example. And that's reflected in this p-value and the fact that that confidence interval is not crossing the no difference line. Now, considering that we're in the equality phase, of course we're relying on p-values. But we can't always rely on p-values, and that's when we get into the clinical setting. So, as you might be hypothesizing, I'm actually going to say that p-values are less important when we get into superiority frameworks, non-inferiority frameworks, and equivalent frameworks. And then you might ask, well, how am I supposed to determine whether or not something is better than or worse than? For example, how am I supposed to make any sort of definitive conclusion? Whoops. Okay, so let's take a look at superiority research questions, or superiority hypotheses. Superiority. We're going to draw the same diagram. Whoops. So we're still going to have that line of no difference. We're going to favor control on this side, favor treatment on this side. But this time, like I said, we don't want to rely on p-values, right, to make any sort of clinical interpretation. So what I have on this end now is what we call a line of important difference. And because this is a superiority research hypothesis, this is going to also be called a superiority margin, or a line of important difference, as I said before. So let me draw a couple of different scenarios. I can draw, for example, this scenario. I can draw this scenario. I can also draw this scenario. Right? So let's look at this one. Actually, let's look at this one first. So again, my p-value is now greater than 0.05. I've crossed that no difference line. My upper boundary and lower boundary of the confidence interval are telling me two different stories with respect to the no difference line. But because this is a superiority study, I'm looking for clinical interpretations. I'm not really interested in p-values. Only my equality studies rely on the interpretation of a p-value. So what I'm more interested in is this line of important difference. So even though I'm non-significant, my p-value is statistically non-significant, I can still make a definitive conclusion. And I can declare that the treatment is non-superior to the control treatment, right? I have to be on this side of the line of important difference in order to definitively declare that my treatment is superior. So here I can definitively declare that my treatment is non-superior. It's not better than, right? Here I can definitively say that my treatment is better than. My lower boundary of the confidence interval, my upper boundary of the confidence interval are telling me the exact same story. My entire confidence interval is on one side of that line of important difference, of that superiority margin, right? So I can say that my treatment is superior to the control in this study. In this study, however, I can't make any definitive conclusions. I'm at a point that is indeterminate, right? Lower boundary of the confidence interval is saying that it's, non-superior. Upper boundary of the confidence interval is telling me that it is superior. Well, which one is it? So again, although my p-value is statistically significant, right? My p-value is 0.05 for this study. I don't know if the difference between my two groups is actually great enough to make any sort of clinical interpretation that the treatment is better than the control. So that's why the p-value becomes less important now. And we have to actually look at a margin of superiority in this case, or in our next case, we can have a look at something called the margin of non-inferiority. So for a non-inferiority study, whoops, let me just change the size of the pen. For a non-inferiority study, I'm going to have the same diagram, but this time I'm looking to declare that my treatment is no worse than, right? So my non-inferiority margin will be on this side. And my hypothesis is that it's no worse than the control. So again, I have a couple of different ways of presenting my results. I could have all of these. Now, if I have this one again, it's pretty similar to superiority. This time, I'm crossing the line of important difference, or the non-inferiority margin, And both sides of my confidence intervals are telling me two different stories. It's either telling me that it's favoring the treatment group, so that it's favoring my alternative hypothesis, so it's saying that, you know, it really is non-inferior, it really is no worse than, or it could just be worse than, right? I'm not sure, so I can't make any definitive conclusion. So here I'm indeterminate. Here, although I've crossed that no difference line, I'm past that line of important difference, that non-inferiority margin. So I can definitively say that my treatment is non-inferior to the control, that the difference between the two groups is greater than this margin. So then I can say that, yeah, my treatment is no worse than the control, even though I have a non-statistically significant p-value. And on this end, again, both sides of my confidence intervals are telling me the same thing. And this time I can say that my treatment is definitely worse than the control, because the difference between the two groups is less than this non-inferiority margin. And then finally, we have one final research question, and that research question is the equivalence research question. And equivalent research questions rely on both the definition of superiority and non-inferiority. So we have same diagram. Let me just write down equivalence here so we know what we're looking at. So we have the same diagram. On this side, again, we're favoring our control. On this side, we're favoring our treatment, right? But this time we need two margins. So we need our non-inferiority margin and we need our superiority margin. And in order to say that something is equivalent, that a treatment is equivalent to the control, our confidence interval has to fall between these two margins. The second they start crossing any of these margins, I become unsure. Is it worse than? Right? Is it better than? Really, I'm only looking to determine that it's equivalent to. So the only way I can be sure is if it falls between the two margins. And that's what an equivalence study is looking for. So all in all, the last three different types of hypotheses that we looked at, the superiority, the non-inferiority, and equivalence, they do not rely on the definition of a p-value. P-value is not important to them. We really need to look at the margins here. And that's really it for this video. Next video, we're going to take a look at measurement properties, so how to look at validity and the different types of validity measures. We're going to take a look at reliability and how we can measure reliability. And we're also going to take a look at how to set some of these margins. We took a look at, superiority margins, non-inferiority margins, and equivalence margins. Well, how do they go about actually setting those? So some people actually call these minimal clinically important difference values, and we'll take a look at how we actually go about setting these minimal clinically important difference values. But that's it for today's video. I hope that helps